Okay. All right. So we're back here, and we're talking about a mid-segment of a trapezoid. So mid-segment is actually also called a median. So you might see those interchanged. All right. I think though a mid-segment might actually be a little bit more descriptive though. All right. So what a mid-segment is it's a segment, all right, that connects the midpoints of the legs of a trapezoid. Okay. Now it can be of any trapezoid. It doesn't have to be an isosceles trapezoid. All right. But let's draw a picture of that. So let's just draw a trapezoid. All right. Let's go ahead and mark our bases. All right. And this is not going to be an isosceles trapezoid. Okay. So what we're going to do is we're going to now eyeball the midpoints of those legs. Oh, that's big. Okay. And then let's mark it accordingly. All right. Where we have one tick mark, two, and two, because it's not isosceles, which means that not all four of those are congruent. Okay. But let's now connect, all right, those side lengths or those midpoints together. And so then this picture right here is going to be a mid-segment, okay? All right, so the trapezoid mid-segment theorem, though, is saying the properties of that mid-segment, all right? So there's multiple things going on here. So the first thing is that this mid-segment is parallel to both of the bases, all right? But that the length of that is 1/2 the sum of the two bases, all right? So what I'm going to do is I'm actually just going to copy and paste this picture into this example, and I'm going to just kind of add some more stuff to it. So I know that mid-segment is parallel, all right, to both of the side lengths. So all three of these, all right, segments are parallel, okay? And so then what we really are creating here, just a heads up, is like we're having corresponding angles, all right, in there. So like, for example, and you don't have to put this in here, but like this angle has to be congruent to this angle, and this angle has to be congruent to this angle, et cetera, okay? All right, the other thing that we have in here is the fact that the length of that segment is equal to 1/2 the sum of the two bases, okay? So let's call this A, B, and C, okay? And A, B, and C are going to represent the lengths of those, okay? So what this is saying is if you have B, all right, and B represents the length of that segment, that's going to be equal to 1/2, and then it's the sum of the other two segments, all right, which means that it's going to be A plus C, okay? So that segment B, all right, is equal to 1/2 of the sum of A plus C. Let's apply that now, all right? So in this example, I'm telling you that MN is the mid-segment, all right? So let's go ahead and mark all these parallel, all right? And if it's a mid-segment, what do you know about M and N, all right? M and N are both midpoints, which means that this segment has to be congruent to this, and this has to be congruent to this. Okay, so if you look at the first one, it's giving us that AB is 13, okay? DC is 25, and we need to find the length of MN, all right? So we know that the length of the mid-segment, so MN, is going to be 1/2 the sum of those two side lengths, all right? So it's going to be 1/2 times, all right, the sum of 13 plus 25, okay? So if we add 13 plus 25 together, I'm going to get 48, okay? Is that correct? Oh, 38. That was bad math, Ms. Jones. Okay. And so you're going to have 1/2 times, all right, 38, all right, which means that the length of that mid-segment is 19. Okay. And that should make sense to you. Like that mid-segment has to be in between 13 and 25. All right. That's all that that's saying. Okay. All right, let's quickly do this next one. So if you look at number 2, it says if AM is equal to 9, then what's the length of MD? Well, we know that that has to be 9, all right, because it's a midpoint. All right, and same idea, if the full length of CB is 7, then what's the length of CN? Well, that's going to be 3.5. Okay, nice and easy. All right, let's try the next one. So this time, all right, we're now given that MN is 15. DC is 18.2. And this time we're trying to find AB, which is X. okay? But we're just going to set it up the same way. The midsegment is equal to 1/2 the sum of the other two bases, right? So the midsegment has a length of 15, and that's going to be equal to 1/2 the sum of the two bases, all right? And this time, though, one of the bases is x, while the other one is 18.2. Now, you could distribute that 1/2 through. All right, I'm going to multiply by 2 on both sides just to get rid of it, okay? So I'm going to get 30 is equal to x plus 18.2. And then if you subtract that 18.2 over, you're going to get x is equal to 11.8. And that's your final answer there, okay? All right, let's go ahead and we're going to do one more, all right? Actually, we'll do 1 and 2 more. All right, so on this one, I'm going to label, once again, MN is your midsegment. All right, but MN, so it says DC is 4x minus 3. Okay. MN is 3x minus 1. And then AB is x plus 5. All right. So I'm going to write this out as almost like a formula. Remember, once again, the midsegment, MN, is equal to 1/2 the sum of your two bases, and in this case, it's AB plus DC. And now if you just write it out like that, it's just a simple substitution step, right? So the length of MN is 3x minus 2, or 3x minus 1, that was silly, is equal to 1/2. And then in parentheses, it's going to be AB, so x plus 5, plus 4x minus 3. All right, and then simplifying what's on the inside, we're going to get 3x minus 1 is equal to 1/2. And we're going to get 5x plus 2. Okay, so you could distribute that 1/2 through. Once again, guys, I'm going to multiply by 2 to cancel that out. All right, but that means I have to multiply this entire side by 2 as well. Okay, so I'm going to distribute that 2 through, and I'm going to get 6x minus 2 is equal to 5x plus 2. And then just quickly solving, you're going to get x is equal to 4. Okay. All right, the last one I want to go over in this set deals with the fact that all 3 of these lines, or these segments, are parallel. All right, so remember AB is parallel to MN, which is parallel to DC. And so on the second one, I have to give you some information. So it says that angle CNM, let's pretend that angle CNM is 80 degrees, okay? And we're going to keep that with both of those. So it says that angle CNM, oh, let's change that. CNM. That's not trying to scale. All right, let's say it's 100. That'll be better. Okay, and we're going to keep it 100 in this one too. Okay, now that's better. So angle CNM is 100 degrees. Okay, we need to find what angle B is. All right, so what I want you to look at is the fact that angle B, so let's look at these 2 lines cut by this transversal. All right, what type of angles is angle CNM and angle B? Well, they're corresponding, all right, because they're in the same location but different lines, which means that angle B also has to be 100 degrees. All right. Then it says that if angle CNM is also 100 degrees, then what about angle C? Well, if those lines are parallel, then angle C and angle CNM are same side interior, which means that they're supplementary, which means that angle C has to be 80 degrees. Okay? All right, we're going to pause there, and then we have one last section to go for this set of notes.